Hello friends, welcome to Learner's Planet. Friends, in this session I'm going to discuss some classic problems in algebra section. We have already discussed the basics, so I will not revise in this session. You must be clear with the basics of algebra. Precisely, you must be knowing the formula for algebra that I have already given you in the previous sessions. Okay, so in this session let's start with the problems. And yes, once again, as always I say, just pause the session when the question appears on your screen. Try to do it on your own and then only just see the explanation in this answer. Okay, so let's begin the session. Now let's take this question. If a plus b plus c is 0, then for the value of this expression. Now most of the students, what they do, as soon as they see the expression, they start taking LCM and start solving it, right? But that will be really tedious process. Okay, first of all, what you should do, just look at the question, try to see if a plus b plus c is 0, then how can you get a plus b plus c? Do you have any option to get a plus b plus c? So I tell you, yes, we have an option. By that we can get by that way we can get a plus b plus c. So when we get a plus b plus c, we put that to 0, then the problem will be simple for us to solve, right? So what I do, see here, a plus b plus c, I add 1 to this expression, 1 to this expression and 1 to this expression. Similarly, 1 to this expression, 1 here, 1 here. I just put one simple over here, part over here, so that will be a plus b plus c by c. Similarly, here it will be b plus c plus a by a, c plus a plus b, c plus a plus b by b, right? So precisely what I'll be getting, a plus b plus c in the numerator, that can be taken as common, and inside the bracket I'll be able to get, and inside the bracket there will be a story, whatever is the story, and minus 3, right? Because since we have added 3 once, that for that I need to deduct 3, right? Now since a plus b plus c is 0 and it can be taken as common, so if a plus b plus c is 0, this entire portion will be 0, right? So it is 0. Similarly, over here it's if we add 1, it will be a plus b plus c, further a plus b plus c, further a plus b plus c, and once again I'll be deducting minus 3. I'll be deducting 3, right? Once again a plus b plus c will be common, and that is 0. In fact, what would happen, see, if you do not solve this part and if you just solve this part, then also you'll be getting a plus b plus c and some story. Now if a plus b plus c is taken as common, then it is getting multiplied by this also and this also, right? So the entire thing will be 0. So if you do not solve it separately, then also it really doesn't matter. Okay, so finally the answer to this problem is 0. Now square root of this expression, I have told you so many times, whenever you see the irrational numbers and you have to find out the square root, 99% cases they must be in a plus b whole square or a minus b whole square format, right? So just look at it, it is 33 minus 4 root 35. When we expand a minus b whole square, what do we get? A square plus b square minus 2ab. So if I see minus over here, it should be recall that it is in a minus b whole square format, right? So it will be a square plus b square minus 2ab. So we see minus sign and then there is a 2, but here we are having 4. So what I do is I just keep 2 inside outside the square root and take the remaining 2 inside the square root. So when the 2 will get into the square root, it will be 4. So precisely it is 33 minus 2 root 140. Now you should be able to choose the two numbers whose sum is 33 and product is 140, right? So 140 can be factorized as 2 into 5 into 7, 7 5s are 35 into 2 and 1 more 2, right? So these are the factors of 140. Now just try to make the combination where you get the sum as 33. So here 28 plus 5, that is 33, right? So it is root 28 minus root 4 whole square, right? 5, sorry. So when you open the square root, you'll be getting 28 plus 5 minus 2 root 28 into 5. Okay, so this is the this is actually this. Now if at all we have to take the square root, that's very simple, just remove this square, so that is the square root. Now root 28 can be written as 4 root 7. If 4 comes out of the square root, it will be 2 root 7. Okay, so that's your answer, and you just have to put up a plus minus sign. Okay, so that's pretty simple. Second thing is, what you can do is, see, you are able to see minus sign over here. So this is plus minus. So forget the numbers which are just having the plus sign. So this is already eliminated. Okay, now for the remaining ones, you just check it very quickly. Like if suppose if this number is the square root, then square of this number must be this. So just check it very quickly whether you are able to get that or not, right? Even here it is plus, so it will be eliminated. Now we check this, so it will be 7 plus 4 into 5, 20. So we got 27 only, and the remaining thing will be in the square root, but we want 33, so even it is not the correct answer, right? So if you don't go for this sort of solution, you can go directly from the options also, because we are talking about competitive exams, and in competitive exams options are there, right? And here if you see, it's 4 into 7, 28 plus 5 and remaining thing. So we got 33, that means this is the correct one. Okay, so I have told you both the methods. You can apply, you can choose anyone that suits you. Okay, now let's see this. This expression is given, and we have to find out the value of x cube plus 1 upon x cube. So what I do is I just write the reciprocal of this to make it simple. So here it is x square minus 2x plus 1 by x. By x, by x, by x is 3. So x plus 1 upon x is equal to, here it is x square by x is x, and 1 upon x is this, and we are left with minus 2. So if this minus 2 goes this side, it will be 5, right? Now x cube plus 1 upon x cube is what? X plus 1 upon x, x square plus 1 upon x square minus 1, right? So what we want x square plus 1 upon x square also. Now if we square this, we'll be getting x square plus 1 upon x square plus 2 is equal to 25. So it must be is equal to 23, right? So x plus 1 upon x is 5, and then it is 23 minus 1, 22. So 5 into 22, 110. Pretty simple. Now there are various methods to solve this sort of problems, right? Since we want the equation in cubic form, and 4 cube is 64, p cube is p cube, and 2 cube whole cube is 8 cube. So something related to cubic of this equation in this given expression or relation or equation, I can say. But to make it the problem simple, what I can do is I can choose the values of p and q which satisfy this relation. Okay, to make it very simple, I take maybe q as 0. So if q is 0, then p will be 4. So p is 4, q is 0, right? So I put up the value of p and q over here. So it is 64 minus 0 minus 0 minus 64. That means precisely you are getting 0. Okay. And if you are not convinced with these values, you can take alternate values also. Suppose you take p as 2. So if p is 2, 2 minus 2q will be 2, then q will be minus 1. Right? Now put the value of p and q over here. So p cube, that is 8 minus 8q cube. Q cube will be minus 1 cube, that will be minus 1. Minus 1 into minus 8, that will be plus 8. Then it is minus 24. PQ will be minus 2. So minus 2 into minus 24 plus 48 minus 64. So 48 plus 8 plus 8, 64 minus 64. Still you are getting 0, right? So the problem becomes very simple if you go this way. Okay. Now to this problem also there are various methods to solve. A square plus b square plus c square plus 3 is equal to this, then the value of 2a minus b plus c is. Okay, the first thing, I just tell you two methods over here. The first method is just put two of them as 0. I just take maybe b is equal to 0 and c is equal to 0. So a square plus 3 will be 2a, right? So precisely a square minus 2a plus 3 is equal to 0. That means a minus 1, a minus, a minus 3 and a minus 1 is equal to 0. Okay, so a is equal to 1 or 3. Now if I put a is equal to 1, then I get the answer as 2 because b and c are 0. Or if I get a is equal to 3, then I'll be getting 6, which is not there in the option, right? So my answer is 2. Alternative method is, see this expression, a square plus b square plus c square plus 3 is equal to 2a minus 2b minus 2c, right? Now here it is a square and plus 3. So I take 1 from this. So what I'll be getting, a square and this 2a I take left hand side, then plus 1. Plus b square minus 2b to left hand side, plus 2b plus 1. Plus c square plus 2c plus 1 is equal to 0, right? So here it is a minus 1 whole square plus b plus 1 whole square plus c plus 1 whole square is equal to 0. Now this is a square term, this is a square term, this is a square term, and sum of these three perfect square terms is 0. That's not at all possible, right? That is possible only when all of them are 0. That means this is 0, this is 0 and this is 0. So this can be 0 only when a is equal to 1. This can be 0 only when b is equal to minus 1, and this can be 0 only when c is equal to minus 1, right? So when we put the value of a, b and c over here, we'll be getting 2, then minus b, that is plus 1, and minus 1, c is minus 1. So it is 2, right? So we were already getting 2. So you can go either way. The important part over here is, see, this is perfect square and perfect square, right? So all of them are positive quantities. So sum of three positive quantities cannot be 0 at all until all of them are individually zeros. Okay, so that is the important part over here. X plus 1 upon x is 4. Value of this just pretty simple, just square it. X square plus 1 upon x square plus 2 is equal to 16. So this must be 16 minus 2, that is 14. Further, x4 plus 1 upon x4 plus 2 is equal to 196. So this must be 194, right? 20 seconds up. Now this very simple, x minus x square we have to find out. So just take this this expression this side. So we'll be getting x minus 1 upon a is equal to minus 1 upon x. And this x minus x square is actually x, if we take common, it is x minus 1 upon x. X into 1 minus x, sorry. Now from here you can see x minus 1 by a is minus 1 upon x. So x minus 1, if I put this negative sign over here, then it will be minus of x minus 1. So that will be precisely 1 minus x. So the value of 1 minus x is a by x. So it is x into a by x, that means a. Okay, pretty simple. Now this problem from power and indices. 3 by 4 raised to 3, 4 by 3 raised to minus 7 is equal to 3 by 4 raised to 2x. So we have to find out the value of x. Now that's pretty simple problem. It is 3 by 4 raised to 3. This is 4 by 3 raised to 7. That means it is 3 by 4 raised to 7. 4 by 3 raised to minus 7. That is 3 by 4 raised to 7. So this is 3 by 4 raised to 3. This is 3 by 4 raised to 7. So in all it is 3 by 4 raised to 10, and that is 3 by 4 raised to 2x. If base is same, power has to be same. That means 2x is equal to 10. That means x is equal to 5, right? When a raised to x is equal to a raised to y, that means x is equal to y. Okay, so pretty simple. Let's see this problem. A plus 1 upon b is equal to 1, and b plus, just a moment, b plus 1 upon c is equal to 1, then value of ABC. See, in this sort of questions, what we can do is we just assume, you have two relations, right? And you cannot assume the values of A, B and C, all of them, because A, B, they have a relationship, and B and C, they have one other relationship, right? So what we can do is we can choose a comfortable value of A, and suppose I take the value of A as 1. Right, now 1 plus 1 by b is equal to 1. That means 1 by b is equal to 0. That's not possible, right? So a cannot be 1 in any case. Instead, just choose a is equal to maybe any other value which does not give this expression to be 0, because that will be not be applicable, because 1 by b cannot be 0 unless in that case b will not be defined, right? So I take any other value, maybe a is equal to say 2. Right, so if a is equal to 2, 1 upon b is equal to minus 1, right? 2 plus 1 upon b is equal to 1, that means 1 upon b is equal to minus 1, that means b is equal to minus 1. Now we got b is equal to minus 1, and I put b is equal to minus 1 over here, then 1 by c will be equal to 1, and then b minus 1, here it will be plus 1. So 1 by c is equal to 2. That means c is equal to 1 by 2. Right, now it has become very simple for us. We have to find out the value of ABC. So this into this into this. So 2 into minus 1 by into 1 by 2, precisely it is minus 1. Okay, so you choose any value, right? Why we did not choose 1? See, 1 is the first option that we can look at. But the thing is, when we choose a as 1, 1 upon b becomes 0. Instead, suppose I take a is equal to minus 1, right? We have other combinations also. Suppose a is minus 1. So in that case, 1 upon b is equal to 2. That means b is equal to 1 by 2, right? A is equal to minus 1, 1 upon b is equal to 2, that means b is equal to 1 by 2, right? When a is equal to minus 1, b is equal to 1 by 2. C, so 1 upon c is equal to 1 by 2, that means c is equal to 2. If at all, once again you multiply all these three, you'll be getting the same value as minus 1. Right, so this sort of problem becomes very simple if you assume the value of a variable. Otherwise, by any other method, if you just keep on taking LCM and then cross multiplication, the problem will become more tedious, right? So this is the easiest way, and your answer is minus 1. Now this problem, pretty simple. Whenever you see this a cube plus b cube plus c cube minus 3abc, just try to recall this format. It is a plus b plus c, a square plus b square plus c square minus ab minus bc minus ac, right? Now we wish to have the value of this expression, x cube plus y cube plus z cube minus 3xyz. Precisely we want this, right? Now a plus b plus c, that means x plus y plus z is equal to 6 is already given to us. A square plus b square plus c square, that is x square plus y square, that's also given, but we are not given this. Okay, now what we can do is I just take just do the square of this. So what I'll be getting, x square plus y square plus z square plus 2xy yz zx is equal to 36. Now this we know 20, so this is equal to 16, so this is 8, right? So it is 20 minus 8. This is 8. So 20 minus 8, 12, 12 into 6, 72. Okay, pretty simple. I hope you are clear. The minimum value of this expression. Minimum value, see here, x minus 2 and x minus 9. Obviously the minimum value will be able to get when we have any number which is smaller than 9 but bigger than 2, right? Then only will be able to get the negative value. Otherwise there is no possibility of getting negative value, right? So bigger than 2, that means this expression will be positive, and less than 9, that means this expression will be negative, right? And the minimum value we will be able to get when these will be when we get a value that is in between, right? That is between 2 and 9. So that's 2 plus 9 by 2, 11 by 2, 5.5, right? So if I take 5.5 minus 2 and 5.5 minus 9, so 5.5 minus 2, it is 3.5, and 5.5 minus 9, it is further 3.5. okay, so it is nothing but, it's negative actually, 49 by 4. Now how do I decide that we should take 5.5 over here? See, we want the minimum value, right? So just put this negative sign aside, because we are going to choose the value between 2 and 9, right? Now what is the possibility to get the maximum product, right? See, if you forget this negative sign, now you try to find out the maximum product. Now maximum product is possible only when we take the average of these two, right? That's why I taken average. Okay, so 9 plus 2, 11 by 2, that's 5.5, and since I have negative sign, I'll be getting, if the product is maximum with negative sign, it is actually minimum. I hope you are clear. Now this problem, a cube minus b cube minus c cube is 0, then this. Once again, here I can smell this format, a cube plus b cube plus c cube minus 3abc. Right now, instead of abc, here we can see a cube, b cube, c cube. So instead of abc, we have a cube, b cube, c cube. So the problem is just one more step we have to do, right? So what I do is, instead of a cube, b cube, c cube, I assume some other variable, maybe x, y, z, right? So a cube is x. See, I am doing paperwork over here just for you. You don't have to do any sort of paperwork, right? Because that will be unnecessarily time consuming, right? A cube is x, b cube I say minus y, and c cube I say minus z. Right? Now a cube minus b cube minus c cube, that is actually x plus y plus z, right, is equal to 0. Now you can see x plus y plus z is equal to 0. That means x cube plus y cube plus z cube will be 3xyz, right? X cube, y cube, z cube, that is this expression. That will be 3xyz, that means 3 a cube, b, a raised to 9, b raised to 9, c raised to 9, and it will be, then this will be equal to this, so finally it will be 0. Okay. Now xy into x plus y is equal to 1, then the value of this. Now once again the problem can be made simple if we put up the value of any one variable and find out the corresponding value of other variable. Suppose I take x is equal to 1, then y plus 1 is equal to 1. I put x is equal to 1, then y plus 1 is equal to 1. That means y square plus y is equal to 1. Right? Now here if I put the value of x as 1, what I'll be getting, 1 upon y cube minus 1 minus y cube. So precisely I need a relation of y cube and 1 upon y cube. So what I can do, we have done many problems, we just have to do one extra step over here, divide the entire expression by y. So this, that means y minus 1 upon y is equal to minus 1. Now y square plus 1 upon y square minus 2 is equal to minus 1, so is equal to 1, so it should be 1, right? I just did square of both the side. Y square plus 1 upon y square plus 2 is equal to 1, so y square plus 1 upon y square is equal to, since it is minus, so it will be getting minus 2, so that side it will be 2, so finally it will be 1, right? Now y cube minus 1 upon y cube is equal to y minus 1 upon y square plus 1 upon y square plus 1. Now y minus 1 upon y, that we know it's minus 1. Y square plus 1 upon y square, that is 1 plus 1. So it is 2 into minus 1 minus 2. Now we obtained the value of y cube minus 1 upon y cube, but here I am having 1 upon y cube minus y cube. So if it is minus 2, 1 upon y cube minus y cube will be 2 only. Now that 2 and this minus 1, 2 minus 1, ultimately it is 1, right? So x is equal to 1, y is equal to 1. I'm sorry, y is equal to not 1. We have calculated the value of this expression. So we put x is equal to 1, then find the value of y, and then this relationship. Okay, and this is going to be very common question. We have done many question on this concept. I hope you are clear. If a plus b plus c is equal to 2s, then value of this is equal to, once again I am going to assume the values of a, b and c, right? Now what I do is, since a plus b plus c is 2s and I want the value of s also, so what I do, a plus b plus c, the value should be chosen in such a manner that it becomes an even number, right? So you don't get a fractional value of s to avoid the lengthy calculations, right? So a, b, c, if I take 1, 2, 3, right? 1 plus 2 plus 3 is equal to 2 into 3. That means a is 1, b is 2, c is 3 and s is equal to 3. Okay, now very simple. S minus a whole square, s is 3, 3 minus 1 whole square, 4. S minus b, 3 minus 2 whole square, 1. S minus c, 0. S square, 9. Okay, a square, 1. B square, 4. C square, 9. 4 plus 1 plus 9, 4 plus 1 plus 9, precisely it is 1, right? So the problem can be done in seconds if you choose the comfortable values of a, b and c. Otherwise any other method will mislead you. Okay, so your answer is 1. I hope you are getting my point. Now this a plus 1 upon a minus 2 is 4, then value of this expression. Now that's pretty simple. Just one twist is there. We have a minus 2 whole square plus 1 upon a minus 2 whole square. So we can compare this with this. Here x is equal to a minus 2, right? So how can I get a minus 2? If I break this 4 into 2 plus 2 and take 2, 1 to this side, so what I'll be getting, a minus 2 plus 1 upon a minus 2 is equal to 2, right? So if you square both the side, you'll be getting square of this plus 2 is equal to 4. So square of this plus square of this will be equal to 4 minus 2, that is 2. Pretty simple. Okay. If the number p is 5 more than q and sum of squares of p and q is 55, then product of p and q is, okay, if the number p is 5 more than q, that means p minus q is 5. P square plus q square is equal to 55. We want pq. Now do I need to tell you the method? Just p minus q whole square it. P square plus q square minus 2pq is equal to 25. P square plus q square is equal to 55. 55 minus 25 by 2 is equal to pq. So 55 minus 25, 30 by 2 is 15. Pretty simple. X plus 7954 into 7956 be a square number, then the value x is. Okay. Could you recall 7954, 7956? Could you recall 7955? This is 7955 minus 1 and this is 7955 plus 1. So it is a minus b a plus b format. So it is a square minus b square, that means 7955 square minus 1, and here we have x. Right, now we want this to be perfect square. So what is the possibility? If we are able to eliminate this and this, then we will be able to get a perfect square number. Right, now how do we eliminate this? It's not easy. What can be done? If x is equal to minus 1, 1, then this 1 and this minus 1 will be cancelled out. Then we are left with just 7955, right? So x minus 1, if it is 0, will be left with 7955 square. That will be a perfect square number. That means x is equal to 1, right? So if you are able to recall this logic, then the problem can be done in 20 seconds, not more than that. Okay? And even you can avoid paperwork also, right? Because if you are able to recall that it will be 7955 minus 1 and plus 1, that is a square minus b square format. So it will be, you can visualize certain things, right? This much can be visualized, right? So you just x plus this square minus 1, that means this x minus 1 must be 0, so that's x is equal to 1. So in fact no paperwork is required, right? If you can visualize to a certain extent. Now x square minus y square is equal to 80 and x minus y is equal to 8 average of x and y. See, even here no paperwork is required. X square minus y square is what? X minus y into x plus y, right? So this is x minus y into x plus y is 80. X minus y is 8, that means x plus y must be 10. Average of x and y is what? X plus y by 2. X plus y we know it's 10, so x plus y by 2 must be 5. So no paperwork is required. This is a square minus 4a minus 1 is equal to 0, value of this. Again, you just can see a plus 1 upon a and all that. Sorry, misprinting was there. So a square plus 1 upon a square plus 3a minus 3 by a. Now here, if I divide the entire expression by a, I'll be getting a minus 1 upon a is equal to 4, right? A minus 1 upon a is equal to 4. I want a square plus 1 upon a square, so a square plus 1 upon a square minus 2 is equal to 16. So a square plus 1 upon a square is equal to 16 plus 2, 18. Okay. Now we know value of a square plus 1 upon a square, that is 18, plus 3 a minus 1 upon a, that is 4. So 18 plus 12, 30. Okay. If the expression is written in this form, then possible values of q are. Okay, what we can do is we just expand this. X square plus x plus 1 is equal to x square plus 2 into x into 1 upon 2, so that is precisely x plus 1 upon 4 plus q square. So x square is cancelled, x and x is cancelled, so q square is equal to 1 minus 1 by 4, that is 3 by 4, so q must be plus minus root 3 by 2. Pretty simple. Now here looks to be a tedious problem. 4 plus 3 root 3 upon this is a plus root b, then b minus a is equal to. Okay, see in the denominator you just see this. We have a square root, right? And precisely a irrational number. I have told you, whenever you see a square root and like this, just try to recall a plus b whole square and a minus b whole square format, right? Since here we have plus sign, I'll be just comparing it with a plus b whole square. So a square plus b square plus 2ab. This is certainly in this format. But if it is in this format, then product, in case of product, we must be having just 2 over here. So 7 plus 4 root 3, what I do is 7 plus 2 root 4, 2 into 2. So 1, 4 I'll take inside the square root. So that will, if it is outside the square root, if it is 2, then inside the square root it will be 4. So 4 into 3, 12. So precisely this number is this. Now you just think of two numbers when sum is 7 and product is 12. So you just immediately you can recall 3 and 4. So this is precisely root 3 plus root 4 whole square. Okay, this number is root 3 plus root 4 whole square, and we have to take square root of this number. So square root of this number will be nothing but root 3 plus root 4 only. Okay, and root 3 plus root 4 is what? Root 3 plus 2. So it is 4 plus root 3 upon 2 plus root 3. Okay. Now we want to have the value of a and b first of all, right? We don't we have to in fact eliminate the square root from the denominator. So what we can do, we can rationalize it. Okay, so here it is 4 minus 3, 1. Now 8 plus 6 root 3 minus 4 root 3 plus minus, I'm sorry, 4 plus 6 root 3 minus 4 root 3, then minus 3 into 3, 9. Okay, so 8 minus 9, it is minus 1 plus 2 root 3. Okay, now this is actually a plus root b. So root b is equal to 2 root 3. That means b is equal to 2 root 3. So b is 2 root 3. Okay, and a is minus 1. So it is 2 root 3 plus 1. I'm sorry, I made a mistake. B should be, actually a is minus 1 and root b is actually 2 root 3. So b must be 4 into 3, 12. Okay, so b is 12 and a is minus 1, so 12 plus 1, it should be 13. I'm sorry for the mistake. I hope you are getting my point. We just have to compare a plus root b to this. This is a plus root b, right? So real part, I'm sorry, this rational part will be equal to rational part and irrational part will be equal to irrational part, right?